Hello, my name is Roy Simpson. I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This lecture for intermediate algebra is focused on quadratic inequalities. These are inequalities that are based on quadratic equations, essentially, except that instead of an equation we have inequality symbols like less than, greater than, less than or equal to, or greater than or equal to. And I've broken up this lecture into three parts. Part A, B, and C. And Part A is what we're going to focus in on this lecture, and that would be focusing on a review of inequalities and interval notation, because I think that often we tend to spend some time away from that material, so it's good to kind of review it. Part B, which will be the next video, will be solving quadratic inequalities graphically. Now, if you've been following my lecture series, you know that I did the same thing when we talked about solving systems of equations. We first had a whole lecture on solving systems of equations graphically first. Then once you get the idea of how to solve them graphically, then we went into solving those things algebraically, which is exactly what part C of this lecture series is going to be. The first thing we'll do is recall just what interval notation actually is. And an interval notation is this stuff right here when we have something like parentheses, -3, comma, 7, parentheses. Or bracket, -3, comma, 7, parentheses. Or bracket, -3, comma, 7, bracket. Or parentheses, -3, comma, 7, bracket. So four different kinds of interval notations, really talking about very similar intervals, but not exactly the same intervals. Parentheses imply exclusion. In other words, if you look at this parenthesis here, it means we're not including -3. This parenthesis right here means we're not including 7. This parenthesis right here means we're not including 7. This parenthesis right here means we're not including 3. Brackets imply inclusion, so that means that in this one right here, we are including -3. In the next interval, we're including -3 and +7. And in the last interval, we're just including +7. Now notice how I wrote that. I put the red for the parentheses, meaning bad, meaning that you cannot include those points, and green for good, meaning that you can actually include those endpoints. One other thing that students often get tripped up on is that you have this something comma something for interval notation. It goes from lowest number to highest number, or in other words, the most negative to the most positive on the number line. So always go from low to high. -3 is to the left of 7 on a number line, so -3 is lower than 7 on a number line. Okay, so if you read through these, that first interval implies that you have all numbers between -3 and 7, but not including -3 and 7. This one right here, which I'll go ahead and actually write out, means that you have all numbers between -3 and 7, all numbers between -3 and 7, including -3, but not 7. The next interval is all numbers between -3 and 7, including both -3 and 7. Finally, the last interval is all numbers between -3 and 7, including 7, but not including -3. This is an easy way to mention a list of numbers without having to write out all numbers in between. By the way, another thing that students get tripped up on, is that they think that this interval between -3 and 7 is just like, oh, you know, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. There are an infinite number of numbers between -3 and 7. Pi is a number between -3 and 7. 1.8828143308 is a number between -3 and 7, and so on and so forth. So there are an infinite amount of numbers that are included in that interval. It's just a very fast notation for stating it. Honestly, the only other thing that I want to do in this video is just write down some solution sets to these inequalities in interval notation, and possibly actually graph them as well, because I think it's good to be able to remember how to graph inequalities on top of this. One thing I should mention here is that each of these is considered to be in inequality notation because you have these inequalities. Less than or equal to's, less than's, greater than or equal to's, greater than's, right? So that's all inequality notation. Well, part A is asking us to rewrite the inequality -2 is less than or equal to x, which is less than 5, in interval notation. The idea is that x has to be less than 5 but must be greater than or equal to -2. In other words, you have a list of numbers that bounce between -2 and 5. If you draw this on a number line, it kind of helps out, actually. So let me go ahead and draw this out. Here's -2, let's say, and here's 5. And I know I can have any number. X can be any number in between those two. It can actually include the number 2, so I'll just fill that in with a solid dot for now. And then I know it cannot include 5, so I'll put an open circle around that. That's a graphing notation that I know a lot of instructors like. An alternative graphing notation, which I prefer, is, well, very close to that. You shade everything in between. If I'm going to include the endpoint -2, then I'll put a bracket there just like I would in interval notation. And if I'm not going to include the endpoint 5, I'll put a parenthesis there just like I would in using interval notation. The reason why I like that is because now when I want to write the interval, I can just look at this notation and go, oh, the interval is bracket -2 all the way up to 5 parenthesis. So let's go ahead and do that again, but this time for example B. And like I've mentioned in the past, whenever I start an example, you should pause it first, see if you could do it, and then unpause it and see if your answer matches mine, or whether I'm wrong. You can always email me if I'm wrong. Let me know. Here we have x is greater than or equal to 10. So again, remember, interval notation goes from the lowest value to the highest value. So let me first start by graphing this. 10, I'll say, is right here. I know that x must be bigger than 10, so it can be any of these values in this shaded region. And in fact, it can even be the stuff beyond there. So I put a little arrow pointing that direction. Since it can include 10, I'll put a bracket opening in the direction of the shading. And that actually tells me my notation. It tells me that my interval notation will start with a bracket, 10, comma, and there's no end to this shading. So in other words, it goes on to infinity. And then, because we can never actually grab infinity, infinity is only a concept, not a number, you have to put a parenthesis on that. Trying this again for example C, we have that x is less than or possibly equal to a -1, or x is greater than 5. So there's two possibilities for my values of x. Actually, well, there's an infinite set of possibilities. Here's -1. Here's 5. Now, the first inequality tells me that x can actually be -1, and it has to be below it, or can be below it as well. So I'll shade everything below -1 here, and I'll just say, yep, it goes on forever. And remember, it can include that. And then I'll hop over to the other inequality, and the other inequality says that x must be greater than 5. So in other words, it could be 6, 7, 8, 9, 10, anything to the right of 5 on the number line. Goes on forever. But it cannot include it, so I'm going to put a parenthesis on that. And that shading tells me what my interval notation is going to be. Because x could be in this region on the left, or it could be in the region on the right, I'm going to have to link up these regions as far as interval notation goes with a union notation. First of all, I'm going to start with the leftmost region here. I know that x can go all the way down to a negative infinity. That's as low as x can go. and it can climb all the way up to a -1 in this region, that is. I know that negative infinity is a concept, so it gets a parenthesis, and -1 I can actually touch, so I'll put a little bracket. So that's one area where x could lie, or that means union, x could start at 5 and climb on to infinity. And remember, infinity is a concept, so we never include that. And 5 we cannot touch, so we write a little parenthesis on that as well. And that's the inequality notation that we would use to denote the interval or the solution set to this inequality. This tells me that x could be anything below or equivalent to -1, or it could be anything greater than 5. Finally, the last example here, D, you have -27.2 is strictly less than x, which is less than or equal to a -4, or 2 is less than x. Now with this one, I think I'm going to kind of clear off the stuff to the right hand side because I want a little more room to do this one. So let me just erase some stuff here real quickly. And what I'll do is I'll try to graph out the first interval that was given to me. So this first interval tells me, let me go ahead and draw a number line here. And if I put on -27.2, and here I'll put on -4, and here I'll put on a 2. Notice that I'm not really putting it in relative position to one another. In other words, notice the distance between -4 and 2 is not really that huge of a distance. It's only 6 units difference. And yet I have almost the same size looking distance between -4 and -27.2. Because I'm just quickly sketching this, I really don't care about how exact my number line looks, just as long as I have the numbers ordered properly. Now that first inequality, it's a triple-sided inequality, and it tells me that x is allowed to bounce between -27.2 and -4. In other words, it could be anything in this shaded area. Can it include -27.2? No. And that's because this is that's a strict inequality. There's no equality symbol underneath it. But because this equality symbol underneath the inequality between x and -4, I can actually equal -4 here. So I'm going to put a bracket there. And then finally, I have or x is greater than 2. So I know that values like 3, 4, 5, 6, or 3.1 or any of those values will work. And I know that I have to be strictly greater than that. So again, we have another what we call compound interval or a union of intervals. And this notation that I use up here really does help out because it tells me in my interval notation is going to be a -27.2, comma -4, bracket, union, start at 2 and climb on to infinity. Okay, I think that's pretty good.